Lower the sonar array to 20 meters.
Copy that. Dropping to 20 meters. Watch the cable tension.
Readings coming online now.
Confirmed, we are seeing strong returns from the deep tow scanners.
Here we see the raw power of the dredging operation. Cutter heads tear into the seabed, pumping the resulting slurry through massive pipes.
Pressure's spiking on the starboard line.
Adjusting the flow regulator now.
Across the deep ocean route, the convoy presses forward, a testament to the power of maritime engineering against the rolling swells.
Using the heavy lift cranes, the team maneuvers the next barrier segment into position, battling the waves and wind.
This is the reclamation zone. Using precise coordination, the barges release their massive payload.
Here we see the initial phase of the reclamation zone, where descending sand clouds are settling onto the soft seabed. The pressurized mixture of sand and gravel is continuously pumped through the pipes, rapidly filling the gaps around the caisson foundations. Utilizing specialized seabed leveling frames, hydraulic arms precisely adjust the depth as the machinery smooths the uneven sand ridges. With meticulous timing, the barges release sand, forming the stratified layers critical to this massive engineering reclamation project.
The deployment of the geotextile layer is crucial, stabilizers beneath the waves.
Utilizing synchronized precision, the heavy ballast blocks are lowered into position, securing the geotextile layers against the relentless force of the deep-sea currents.
In this shallow reclamation zone, amphibious bulldozers spread vital material as the tides wash over the newly exposed ground.
Here on the reclaimed land, heavy compactors employ intense pressure, visibly expelling water from the saturated sand to ensure stability.
The sensors are showing increased pressure on the west side. We need to adjust the flow rate immediately or risk breach.
Copy that. Adjusting pump output now. Alignment looks good on grid reference B4.
Confirmed. Ready for insertion cycle 1.
Monitoring pore pressure now.
Utilizing overlapping compaction paths, the team ensures the artificial island meets strict settlement criteria.
Behind the rock armor barrier, a synchronized fleet of heavy machinery works to pump and shape the sand film, rapidly reclaiming the land from the sea.
Using advanced GPS technology, the team ensures the elevation is precise, transforming the seabed into stable, usable land.
Seismic readings are stabilizing at 40 meters.
Confirmed. Vibration levels are within acceptable parameters for this load.
Keep coming straight, watch the left side.
All right, hold it there. That looks good.
Maintaining a steady cycle is crucial. The geometric precision of the leveled plots and utility hubs is now complete, a testament to years of planning. The CPT data confirms the stratification we expected in Zone 3.
Agreed. However, the shear wave...
Roads, utilities, and foundations demonstrate
We need to deepen this channel according to the plans, at least 3 meters down. Roger that.
Directing the bulldozer to stabilize the slope at Tango 6.
Easy now, easy. Looks good.
Confirmed alignment. Set it down.
The settlement looks consistent across the grid.
Yeah, the vibration seems to be doing its job.
All right, hold the tension on the crane. We're setting the seal on section 3.
Tension stabilized. Looks good. Secure the joint.
That section is compacted.
Agreed. Levels look good.
All right, pull it up and move to grid reference, Charlie.
continuous pouring is critical here. The rebar cages must be perfectly aligned as the concrete fills the vibrating steel molds.
Check the tension on line 3. It's reading low.
Increasing hydraulic pressure now. Monitor the deflection.
Pressure levels look good on the left caisson.
Confirmed. Beginning final descent sequence now. This specialized perimeter construction requires precise timing to inject the sealant effectively against the force of the surging waves.
Engineers move quickly to seal the joints, ensuring the integrity of the chamber deep beneath the surface.
Precision is paramount, as the conduits are guided by rollers and secured into the main support structure.
Check valve 7. Are we holding pressure?
Affirmative. Readings are nominal.
Utilizing heavy machinery, crews begin the complex process of backfilling the utility hub excavation with layered aggregate, grates and gates, ensuring precise flow regulation against the tidal pressures. Utilizing high aerial views, engineers confirm design levels across the vast interior zones. Graders smooth the
Lower it slowly now. Watch the guides.
elevators shape the new stormwater channels, critical for island resilience.
All right, hold tension on the east cable. We're almost seated.
The precision involved in setting these isolation pads is extraordinary.
All right, slowly lower the cover. Watch the alignment. Hold it right there. Ease it down, easy.
Freely. The pavers advance steadily, laying down the critical asphalt base layer. Immediately behind,
The central utility hub demands precision. We're lowering the primary support structure now. Alignment is critical.
In this vast landscape, engineers meticulously oversee the alignment of the precise grid.
Even as here at the perimeter, engineers are finalizing the gradients as excavator. Wind speeds are spiking over 50 knots.
Confirmed. The masts are flexing considerably. Keep monitoring the strain gauges.
Readings are stabilizing across the board. Confirmed. The primary pumps are synchronized. We are running at full capacity.
The scale is almost incomprehensible. Kilometers of engineered land, a precise geometric
The
grid.
resonance is spiking again.
Look at the vibration data for Sector 4.
We need to adjust the suspension parameters immediately.
Using state-of-the-art pile rigs, crews drive supports deep into the bedrock, laying the foundation for the elevated corridor.
Engineers are now installing the final grade. Utilizing a synchronized dual crane lift, the crew guides the critical span into position, battling the elements every step of the way.
Status on the central supports. Are we aligned?
Affirmative. Crane is ready for the next beam placement.
Wind advisory is green. Proceed as planned.
Flying in air valve, bring it Phil. Arrow.
Check the alignment on that far pylon. It looks slightly off.
Reading confirmed. Initiating secondary scan now.
This footage shows the interior drainage network during a controlled release. The channels fill rapidly as the pumps in
Ghost Island. All systems now active and
The articulated arms apply a high-grade protective epoxy to the steel reinforcements, critical for long.
These engineered berms, now stabilized with native vegetation, provide a vital layer of defense against rising sea levels.
System stabilizing. Looks good.
Confirmed. Stable idle achieved. Make sure the excavators stabilize the load before traversing that section.
Copy that. And keep an eye on the wind shear up there.
Tug 1, confirmed detachment sequence complete.
Gangways are secured, moving to open water trajectory.
Copy that. All vessels proceed as planned. That last wave generated significant impact pressure.
Confirmed. Sensor array 3 is showing elevated stress readings.
These floating caissons, weighing thousands of tons, are being maneuvered into exact alignment using
Weeks of preparation culminate in this delicate operation, guiding the floating giants through the channel currents. Active and stable. With construction complete and machines minimal, the platform stands ready against the open sea.
Rainfall intensity is increasing. The main pumps can't keep up.
We need to reroute auxiliary systems now.
All right, team, interior checks are complete. Let's verify the seawall integrity before the next high tide.
Confirmed. Moving to the perimeter now.
Calibration sequence initiated on Hub 7.
Readings are stabilizing. Confirming data integrity now.
The repeated wave cycles exert tremendous force on the caisson wall, necessitating constant observation by the engineering teams.
All right, everything looks good here. Let's head out.
Copy that. See you tomorrow.
The completed artificial island stands as a testament to modern engineering, featuring intricate networks of roads and viaducts. Expansion relies on a continuous flow of material. Engineers carefully choreograph the movements of these heavy machines to maintain the construction schedule.
Here at the island perimeter, massive wave barriers are constructed to withstand the storm's fury. Utilizing hand signals to cut through the roar of the surf, the crew guides the crane operator in the precise placement of the tetrapods.
As we pull away from the breakwater, the scale of the challenge becomes clear. Wind and waves dominate this exposed offshore environment. Reading confirmed at marker 42. Documenting. Levels look good for the coastal buffer zone. At golden hour, the structural integrity of the coastal highway is meticulously assessed, ensuring resilience against the encroaching sea. Messages. From this altitude, the sheer scale is revealed. The island's infrastructure, from viaducts to utensils. The simultaneous activation of every zone.
The structural integrity seems stable, but look at the cavitation here.
We should recommend reinforcement for the next phase.
The lighting grid on Sector 3 is fully operational.
Confirmed. Power consumption is stabilizing across the seawall. Here at the perimeter, the wind and water relentlessly batter the seawall and drainage systems, revealing the natural wear on the materials. This cinematic tracking shot reveals the harsh reality of coastal engineering. Wind-driven mist carries...
As the sun sets over this coastal landscape, the true scale of the elevated highway becomes apparent.
As the sun rises over this modern metropolis, the intricate network of roads, viaducts, and utility hubs becomes clear.